Okay, let's look at this example of a net present value. We're asked to solve for the net present value of a project. And so we have some company, they have a special investment. They have a project that needs two machines, 25,000 for one, 10,000 for the other. Both machines are required. We're not comparing two different machines. The total residual value is 1,000 at the end, and it's going to generate $11,000 of cash inflows over its 10-year life. We can solve this using time value of money tables, which I will show you here, or Excel, which I will also show you here, if that is made available to you for your instructor. If you are taking this exam in the online testing center, unfortunately Excel is not available for you there. Okay, and this company has a 6% return. So if they require a 6% return, what's the present value of the table? So I'm going to set this up in a table format, and this is exactly how I would recommend that you do it. We have an initial investment, we have cash inflows, we have a salvage value. I've written the amounts out, and the signs matter. So the outflow, the initial investment is an outflow. It's minus 35,000. That's the 25,000 plus the 10,000. We have annual cash savings of 11,000. That's an inflow. We have a salvage value at the end of the 10 years. That's an inflow. When do these things happen? The initial investment happens now. The cash flow inflows are years 1 through 10. That's how we know it's an annuity. It's a constant number over time. And the salvage value happens one time. That's in year 10. The present value of any dollar today is $1, so the present value factor is 1. So we know the present value factor, or excuse me, the present value of the initial investment is minus $35,000. Okay, so using the tables, and you probably just be given this information, the present value of an annuity of $1 at 6% for 10 years is 7.360. This is an annuity, the cash flow that happens over and over and over. So I'm going to put that factor in 7.360. The present value of $1 or a single sum at 6% for 10 years, 0.558. This is a one-time amount. It happens at the end of year 10, 0.558. Now I just extend out the math. So my present value of the cash flow for my inflow is the 0.736 times 11,000. And my present value of the salvage value is 0.558 times 1,000. And then I sum these three cash flows to net them to get net present value of 46,518. Meaning this has a positive present value, and so it's something that they should do. I'm also going to show you how to do this in Excel. So the Excel formula for the present value of the cash inflows is going to be PV, open parentheses, 6%, comma, 10, comma, that's the number of years, minus 11,000, that's the reoccurring payment, minus 1,000, that's the cash flow, the salvage value at the end. And the way I usually set up the formula when I use Excel is I take the initial investment, which is already at its present value, and I compare it to the present value of the cash inflows to get the net present value. And in this case, I think we have a difference of 1. Yeah, we have a difference of 1. And actually, this is the more accurate of the two because the tables, round a little bit. Excel doesn't round. So, and then how did I get the 81,519? It is literally this formula right here.